All right, let's look at the hyperbolic identities. All right, so as we said before, hyperbolic sine is an odd function, and the hyperbolic cosine is an even function. And that's just the definition of odd function and definition of even function for number one and number two. All right. And let's just check. It's just a tedious check. So if you start out with the left-hand side, so I'm going to just start with the left-hand side of the equation, which is um, a hyperbolic sine of negative x, right? So using the definition, hyperbolic sine of negative x is e to the, you have to plug in negative x minus e to the negative x over 2, right? So that's the hyperbolic sine of negative x. All right, but you can see that there's a double negative, so that's going to be positive here. All right, then I'm going to pull out the negative sign out, right? Then I'm going to change the order. So 2 is on the bottom. All right, so we have a negative sign it's pulled out, so I'm going to have this guy which is just e to the x, right? All right, and positive negative x, but since we pulled out the negative sign, it becomes a negative e to the negative x, right? Which is the definition of negative hyperbolic sine of x, which is the same thing as the right-hand side of the equation. All right, so this verifies that. All right, and number 3 is probably the most important one. The reason why this is called hyperbolic is that remember that if you're looking at the sine and cosine function, we have the identity for trig function cosine squared of x plus sine squared of x is actually, maybe I'll use angle. How about this? Theta plus sine squared of theta is equal to 1. All right. And so this is the trig identity, probably the most popular one for trig function. And this has a close connection with the unit circle. So cosine x squared plus y squared is equal to 1. Right? So trig function has a close tie with the circle, unit circle. Right? And if you look at the number 3, and we have hyperbolic cosine of squared. In this case, I'm using x here. And then hyperbolic, oh, actually, it's a minus. Hyperbolic sine squared of x is equal to 1, right? And this has a close connection with the x squared minus y squared is equal to 1, right? So that's an equation for hyperbolas. So that's why this is called the hyperbolic function. So there's a connection with the hyperbola. All right, and if you want to verify this equation, so let's start out with the left-hand side again. All right, so we have to hyperbolic cosine squared. So we have to squared e to the x plus e to the negative x over 2 squared minus e to the x minus e to the negative x over 2 squared. All right. So to get squared, so the denominator is going to be a 4 for both terms. So I'm going to just put the big 4 here. All right, so if you square the numerator, you have e to the 2x plus 2 times e to the x times e to the negative x, which cancel each other out, plus e to the negative 2x, minus, if you square that numerator, e to the 2x, minus 2 e to the x times e to the negative x, and plus e to the negative 2x, right? Then you can see that you can cancel e to the 2x and minus e to the 2x, e to the negative 2x minus e to the negative 2x, and e to the x times e to the negative x gives you 1. Same thing here. Then what you get is you have 2 minus negative 2, 2 plus 2, so 4 over 4, which is 1, which is the same thing as the right-hand side. So this verifies. So number 3. Oops. Right. All right, and all the other ones can be, verified using a definition and just basically work it out. So I'm not going to go through all of them because it's kind of boring, but you can easily prove the rest of the identities as well. All right, that's it. I hope that this was clear.